solve, this was from that other day, and I'll give you a few easy ones to start. So we'd go 4 to the x plus 1 equals 8 to the x minus 1. What base can I make them both be? 2. Okay, so you're going to try that one. Not B. How do I get 1/9 to be not that way? If it's 9 is 3 to the 2, what am I going to make it be so for it to be 1/9? 3 to the negative 2. Yeah, 3 to the negative 2. So try these two out, and then I'm going to give you one like they actually give, which is hard. What base can I make these all, the first two be? We said base 2. We always make them be a smaller base, not a large base. So this would be 2 squared. And then what people, I always put the exponent in brackets so that people remember to distribute, because the answer to you not remembering to distribute will be there, correct? But you should be able to catch that you're wrong, because you'll get an answer, you'll try to plug it back in, or you'll use your calculator and they will not match, right? Then 8 is 2 cubed, x minus 1. Then we expand, so we get 2 to the 2x plus 2. Equals 2 to the 3x minus 3. And then once our bases are the same, we can say if this base equals this base, then the exponents must be equal. So we get 2x plus 2 equals 3x minus 3. Subtract 2x. 2 equals x minus 3. Add 3. X equals 5. And then we can check it two ways. We can plug it back in. We can go 4 to the 5 plus 1, so 4 to the 6. And then 8 to the 5 minus 1, 8 to the 4, and they'll match. The other way we can do it is using our calculators. We always type in the original. So we're going to get 4 to the power of x plus 1. Now, if you're someone with an older calculator, if you're someone with a TI-83 or some of the TI-84s, and the exponent does not pop up, you know what I mean? You get 4 and then you get a roof symbol and then the exponent doesn't pop up. You have to put the exponent in brackets. If you do not, it doesn't know that it's 4 to the entire exponent x plus 1. Okay? So if you have the older calculators, you need to make sure you put x plus 1 in brackets. And then we have 8 to the power of x minus 1. And then I press graph. My window's weird, so I'm going to go zoom 6. Then I don't care where it's crossing, I'm going to try it. Second, trace 5, enter, enter, enter. So whenever it says solve, and I have two equations, one on each side, I can always y1, y2, and find out where they intersect. It'll always give me my answer. So it's always a way I can check it. And it says x equals 5. I don't care what the y is. The y is not helpful. Okay? It's the x that matters. So the answer is 5. I have 5. I am happy. I am right. I move on. So remember, we do second, trace, 5, enter, enter, enter. And some people are like, well, I can't see it intersecting. Of course you can't. It's at 5 and 4096. I'm maxing out at 10. You're not seeing where it's intersecting, right? But it is somewhere up top. Okay? So it's just like what we did last year when you guys did, well, mainly it was the year before when you did linear systems, and you had to learn how to do by substitution, elimination, and graphing. This was the graphing portion, where you put your two equations in, and you find out where they intersect. Okay, this one, we discussed this previous to doing it. 1 over 9. Well, 9 is 3 squared, so 1 over 9 is 3 to the negative 2. That's a rule from grade 10 as well. 2x plus 1 equals 27 is 3 cubed. X plus 1. So I'm going to get 3 to the negative 4x minus 2 equals 3 to the 3x plus 3. And then we get negative 4x minus 2 equals 3x plus 3 because the bases are the same. Then I can add my 4x over. Negative 2 equals 7x plus 3. Subtract 3. Negative 5 equals 7x. Divide by 7. X equals negative 5/7. Now instead of freaking out and being like, I wonder if I got it right or not, you could plug it in and see into the x's and see if the left side equals the right side. Or we can do this again. I don't know what I just did. I did split screen. I don't want to split screen. Okay. Sure, I'll leave it split on this. Okay. So we put in our original. How do we put in a fraction? Always in brackets. So 1 divided by 9, or alpha y equals, if you have the calculator like I do, 2x plus 1, 27 to the x plus 1. Now, if it was the older calculators, you have to put that exponent in brackets, right? Mine, I didn't need to. I just did. So I press graph. And then I go second trace 5, enter, enter, enter. And I get this decimal, remember? And I taught you guys how to move the decimal back to a fraction. So now your x is that. So I can go second mode and get out of it. And I can go x, enter, and there's the decimal. Math, enter, enter, and there it matches. It's the exact same. So I'm not freaking out when I see negative 5 over 7, because I got the answer. It matches. No freak out needed. I got it right. Now, they might make your question harder. And by might, I mean if it comes on the diploma, it's always harder. So what they'll do is something like this. So if we go 5, oops. If I go 5 to the x plus 1 over 25 to the 2x plus 1 equals 125 to the 2x minus 2. So in the previous ones, I just had exponential base to a variable exponent on both sides, correct? But now I have this division happening on the left. Now, how can I put a division together? The only way you can put a division together is if you have common base. Now, when we had common base, we had 2 bases and 2 exponents. What did we do with the exponents? If you had like 5 to the x times 5 to the 2, we would get 5 to the x plus 2. You added the exponents, remember? Same base, multiplication, you add the exponents. So if we have same base and we divide, what are we going to do to the exponents? Subtract. So we need to first get the same base. So we're going to get 5 to the x plus 1 over, what's 25? 5 to the 2, 2x plus 1. 125 is 5 to the 3. Then I have to distribute. So I'm going to get 5 to the x plus 1 over 5 to the 4x plus 2 equals 5 to the 6x minus 6. Now, what happens is people will just drop off the bases and write it as x plus 1 over 4x plus 2, which is not the actual answer. I have same base and I'm dividing. I want them to be one base. So if I have the same base and I'm multiplying, I add the exponents, correct? Same base and I divide, I have to subtract. This is, if people can get this step to the next step, correct, they're golden. But a lot of people can't get there. So I'm going to get 5 to the x plus 1 minus 4x plus 2. You have to subtract exponents. Equals 5 to the 6x minus 6. Distribute your minus sign through, try and solve it. We're going to get 5 to the x plus 1 minus 4x minus 2 equals 5 to the 6x minus 6. Then I can collect like terms. So I get 5 to the x minus 4x is negative 3x. Plus 1 minus 2 is minus 1. Equals 5 to the 6x minus 6. And now that I have the same base, I can set the exponents equal. So I get negative 3x minus 1 equals 6x minus 6. Add 3x. Negative 1 equals 9x minus 6. Add 6. 5 equals 9x. Divide by 9. X equals 5/9. And we're going to y1, y2 this. So here's my original. I want to type my original in. So I'm going to go. If I have the old calculators, I have to do this differently. I'm going to have to, if I have the old calculators, I have to put the top in brackets divided by the bottom in brackets. If I have the new calculators, I'm going to go alpha y equals enter. And I'm just going to type it in the way it looks. Excessive, not x. So I type it in just the way it looks. If you have the older calculators, you have to put the full top in brackets divided by the full bottom in brackets. And you also have to have your exponent in brackets. So there's going to be a lot of brackets. Then I'm going to go second, trace, intersect. I want to find out where they intersect, the x value. Enter, enter, enter. And I get this 0.5 repeated. Math, oops. X, enter. Math, enter, enter. Just 5/9. And what did I get? 5/9. I know I'm right. Move away. I feel happy about myself. I got it correct. Right? Okay, we're going to flip to the notes I gave you. We're going to do word problems. There's 3 different types for exponential. On the test, you're going to have one of each type. So if you're like, oh, I hope she doesn't put many on, she's going to. She's me. So this is type 1, this very first one. It's appreciation and depreciation. Why is it frozen? Oh, now it's like this. Okay, it's appreciation and depreciation. None of the formulas are given to you, so you need to have them memorized. It's not on your formula sheet. Leave you lots of stuff if they don't give you these. So, the appreciation and depreciation formulas are just ones where appreciation means you're increasing. Okay? Now, this one is 1 plus I. And I is your interest rate. So 1 plus means we're increasing, right? We're getting larger. Now, what is 1 as a decimal in a percent? Yeah.
0.01.
Nope. What is 1? The whole number 1, what is it if I use that as a decimal? What would that be as a percent? Yeah. Anyone know? Yeah, if we want 100%. So 1 as a decimal is 100%, correct? So if I go, I'm increasing by 3%. I would add to this, not a 3, I would add to this 3% as a decimal. What's 3% as a decimal? 0.03. So that's the reason why we go 100%. If I have 100% of the original value, have I increased or decreased or anything? If I have 100% of it, I've stayed the same. So that's why you use 1, and then you add the interest rate if you're increasing, and you subtract the interest rate if you're decreasing. And we always add it in a decimal form because the 1 is actually 100%, it's just in decimal form. Okay? So, F represents our final amount. So we're going to write that in here. It's our final. That's the final amount that you end up with after it's increased. I, this capital I, is the initial value you start with. Little I is the interest rate but it's in decimal form. So if it's 3%, you would put it in as 0.03, sorry. Because you just take whatever it is and divide it by 100, right? And then you have decimal form. And n is the number of years. Now, the depreciation formula is the exact same, except I go 1 minus I. Why would that be? Yeah. You're going lower in value. So you start off with 100%, and then you're decreasing it by however much. So the key thing is, if I'm decreasing it by 10%, I'm actually going to have 0.90 in this bracket, right? And people will tell me, oh, you decreased it by 90%. No, you didn't decrease it by 90%. You decreased it by how far away that is from 1. Right? We start off at 1, and now I have 0.90. Well, I went down by 10, so I'm decreasing by 10%. If this value was 0.75, I didn't decrease by 75%. I decreased by how much? 25 to get me to 75, right? If I increase by 25%, this bracket's going to be 1.25. So it's how far above 1 it is how much I increase by. How far below 1 it is how much I decrease by. Does that make sense? Increasing, decreasing. Okay. How do I spot these questions? Well, they'll just be a basic, like, I start off with this much money, I end with this much money, I start off with this much fish, I end with this much fish. I'm increasing the fish or I'm decreasing the fish. Basically, that's what it is. Or I'm increasing the car amount or I'm decreasing the car amount. So let's look at this question. So it says here, the initial price of a car is $30,000. The value of the car depreciates by 20%. If the car is new in 2005, how much will it be worth in 2010? Now remember, when you do physics or chemistry and they give you a formula, the only way you can solve the formula is if you're missing one unknown. If you have one unknown, you can solve it. If you have more than one unknown, you have the wrong formula, or you don't have enough stuff filled in. You can only have one unknown. That's part of a formula, correct? So we know the initial price, so we always write our knowns out. If you do that, it'll help you out. The initial price is $30,000. So which of those variables is it? Yeah, the capital I. Capital I is 30,000 because that's our initial. The value of the car depreciates. What does depreciation tell us? Which formula are we going to use? We're going to use the subtraction one. So we know that this depreciation tells me we're using final equals initial, bracket 1 minus I to the n. People call me over and they're like, what is this? What do I fill in for this? I'm like, it is a 1. You fill in nothing. It's a 1. Because 1 is 100%, right? Now it depreciates by 20% per year. What does that go in for? Yeah. So my I, 20%, I would have to do 20 divided by 100, which is 0.20. If the car is new in 2005, how much will it be worth in 2010? What does that give me? Nope. It's you're counting it like 2000. You're counting it like 20-1. We are going by the number of total years. So you would go 2005 to 2006 would be 1 year. 2006 to 2007 would be 2. 2007 to 2008. 2008 to 2009, 2009 to 2010, so it's 5. These ones are way easier than last year's geometric and arithmetic series questions all the time, where you'd have to like subtract them and add 1 every time because it counted your 0 term. Here we're counting how many years it takes. So 2005 to 2006 is 1 year. So all we just have to do, these ones are really easier than last year's, you just subtract them. So n is going to be 2010 minus 2005, which is 5 years. What is it making me find? The final value. How do I know that? It's the only thing missing, even if I was stuck, right? So it's always better to list your knowns. So the final is what I'm looking for, because it says, if the car is new in 2005, how much will it be worth in 2010? So it's asking me for my final. You have to watch. Sometimes they ask you to find the initial and they give you the final. Sometimes they ask for the final and they give you the initial. So let's fill it in. We have final equals 30,000. Now, should my final be bigger than 30,000 or less than 30,000? Less because it's depreciating. If it's greater, you have problems. You did something wrong. Then it's 1 minus 0.20 to the 5. So I'm going to get F equals 30,000, 0.80 to the 5. Everyone type it in and see what you get. It's money, so unless otherwise specified.
It's like sig fix, right? 'Cause it's 20%.
We don't do sig fix. But I hear you. But we don't do that here.
Okay, I rounded it to 2. That's my fix.
Yeah, you would because it's money.
Okay.
Yeah, unless they say whole number.
Oh, okay.
And on the diploma and on any of the tests, they have to have a rounding rule.
Oh, okay.
So we don't do sig figs, but we do rounding rules.
All right.
Yeah. Okay, so what do we get? Who has the answer? Ready? $1,830. Now, if this was a test, it says, how much is the car worth in 2010? You have to have a sentence. And these ones are the easiest sentences to make. You're rewriting, just rewording that question. So, the car will be worth $9,830.40 in 2010. Do we all agree? Everyone get that? So that was a lot more straightforward because we're not having to solve for the actual exponent. Now this is in exponents, the unit exponents and logarithms. And the reason why is often they'll make you solve for the actual n. Do you see how the n is the exponent? They'll make you solve for that because that's what this unit is for. This unit is for solving for the variable exponent. So let's look at B. B says, how long will it take to the nearest tenth of a year for the car to be worth half of its original value? So they're making us look for n. We need to have the rest of the things in order to do this. So my initial is still 30,000. My interest rate is still 0.20. What changed? Final is what? 15K. Because it's half of the original. So we're going to fill it in. We're going to get final, which is 15,000, equals initial, which is 30,000. Bracket 1 minus 0.20 to the n. So we get 15,000 equals 30,000, 0.80 to the n. Now in order to solve this, in order to solve any of these, this is something to note in your head. If you're given the final and the initial, once you've filled in your formula, the very first thing you're going to do every single time is divide the initial over. So if you have the final and the initial, if you have both numbers, you are going to divide that initial over. Because if you're going to type in your calculator, it makes your screen way smaller. If you're going to do math, it makes the number way smaller. Okay? So our very first thing we're going to do is we're going to divide this 30,000 over. If we have the final and the initial, that's the first thing. Because this 30,000 can't, these two, look here, these two cannot multiply together. Do not go 30,000 times 0.80. 0.80 is to a variable, to an exponent. You can't put these together. We can divide the 30,000 over to 15 because it doesn't have an exponent. So that's what we're going to do. Divide the 30,000 over. And we get 1/2 equals 0.80 to the n. We can use our calculators right now to find this out, so we can go y1, y2. Everyone's trying it out in your calculator, because just because I can do it doesn't mean you can. Just because the person beside you can doesn't mean you can. So your y1, y2. Instead of a half, you can put in 0.5. It is the same thing because it's terminating decimal. y1, y2. So we have 1/2 or 0.5, and then the other one is 0.8, 8 to the x. It's x t theta n, it's the same thing. And I press graph. Now, your calculator can only calculate what it can see for x's, so if it gives you an error, it's because your x max isn't big enough to find. So 90% of the time when you get an error doing these questions, you just need to make your x max bigger. This one is fine. I can see where it crosses. So I'm going to go second, trace, 5, enter, 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 and I get 3.1. Is that an 8? It's hard to see. Or is that a 0? I think it's a 0. Yeah, it's 3.106, and they want it to the nearest 10th. So what's it going to be? 3.1.
We ever have to show our work finding?
You will, because I have to show you how to solve it by a log, and you haven't learned that yet. So right now, the only way we can answer these is our calculator, unless you make common base. Okay, I'm going to get you guys to try example 2 and example 3. Done. So here it says the population of the city was 250,000. Now we have to read really, really well to go through and make sure we know if it's the initial or the final, right? So here it says the population of the city was 250,000 on January 1st, 2000, and 310 on January 1st, 2008. So the 250,000 is the initial. And the final is 310. Is this growing or decaying? Growing, because I'm going from 250 to 310, right? So I know I'm going to use the formula with the plus, because that gives it away. If the growth rate of the city can be modeled by an exponential growth function, the average growth rate. So they want the I. How do I get the N?
2008 times 2000.
Yeah, it's the years on the amounts. So 2008 minus 2000 is 8. So I'm going to get final, which is 310,000, equals initial, which is 250,000, bracket 1 plus interest rate, which I don't know what it is, and n is 8. What did I tell you? If you have the final and you have the initial, what's your very first step? Divide them. If you do that, you're in a much better boat. If you forget to do that, things get ugly. You have to remember to do that. So if you have both, you divide them. Oh, come on. Sure, I don't want to change my marker color anyways. So you're going to get 31 over 25. All those are going to cancel. And I told you the only way you're solving these out right now, you could solve this actually mathematically. Because the only one that you have to do y1, y2, you have to do y1, y2 for right now is n. Because I haven't shown you how to do the log. But you can solve this one. It's not the exponent that's missing. So I take the 8th root. I like literally will not do what I want. So I take the 8th root. So in your calculator, you're going to go 8 math. Eight math number 5, because it's going to put the 8th in the root spot. 8 math number 5. If you have the older calculator, it's just going to have an 8 beside it, but it's going to do it. And then we're going to do 31 divided by 25. Enter. So we get that. Am I allowed to round before the answer? No. I won't be able to see that anymore, so I just want to do it. Let's do it up here. Oh. If you have the old calculators, you need to put 31 divided by 25 in brackets, correct? Or your calculator doesn't know it's a fraction, which I just did not do on this calculator. Bless you. So we get 1 decimal 0.027253692 equals 1 plus I. Then how do I get I by itself? Subtract 1. So I equals, and now it wants to the nearest tenth of a percent. So I have 0.0272, etc. How do I turn that into a percent? Times by 100. So I equals 2.7253692, and they want it to near 10%, so it's 2.7%. Okay, example 3. In 2002, the population of a city was 160,000 and was increasing at a rate of 4.5. It should have a percent symbol. I don't know how I got that. Didn't put it there. Write an equation to represent the population P of the city and a function of the number of years N since 2002. So, what is 160? The initial. I don't know what I was doing. 160,000. My final, they're saying represents as P. So F, they want as a capital P. Number of years, they want as N. What's the interest rate? 0.045, because you go 4.5 and you divide it by 100. They just want the equation with P and N being P and N, not solving for anything. So we get P equals 160,000, bracket, 1, now am I increasing or decreasing? Increasing, so I'm going to go 1 plus 0.045 to the N. So I actually get P equals 160,000, bracket 1.045 to the N. Can I make it more simple? Can I take the 160,000 and divide it, or and times it by the 1.045? No, I can't put those two together. That's as simple as it gets. That would be the equation answer for A. Then they want the population in 2005. So do I know P or do I know N? N, and how do I get it? 2005 minus 2002. N equals 3. So I get P equals 160,000, 1.045 to the 3. And it's people, so you are going to round down every single time because you can't find partial people to round up. So it says 182,586.58. We can't find 4/2 of a person to round up, so we always round down when it's people, cattle, frogs, I don't know, anything that has a whole thing. So 182,586. Here it says, if the population continues to grow at this rate, determine the number of years to the nearest year for the population to double. So I'm looking for N, and I need to have my final. What's my final going to be? 320,000, because it wants it to double. 320,000 equals 160,000. Bracket 1.045 to the N. I have my final and I have my initial. What's the very first step I have to do? Divide. Tis true. So I get 2 equals 1.045 to the N. How do I solve this when I don't know N right now? Put in your calculator, y1, y2. Go, try it out. Can't do algebraically yet? That's not tell you how. You're going to have to convert it to a logarithm. So a lot of you are going to be punching it in and it's going to say error, no sign change. I hope that's what you're seeing. So what did I tell you? If you get error, no sign change, it just means that it can't see where they intersect. So what do we need to make bigger? Your X max. That's it, your X max. So I'm going to go to my window, and instead of my X max being 10, I'm going to try 20. I'm not going to go 10 and then do a million. There is something as too much, okay? So I have to be able to see it, and at 20 I can see it crossing. So I go second, trace 5, enter, enter, enter. So with 20 I can see it crossing, and I get to the nearest number of years to the nearest year. N is going to equal, I have 15.7473302. So what's that? 16 years. Now for all of these we should have sentences. So here this one should say the population will double in 16 years from 160,000 to 320,000. Okay? Then we're going to flip over. We have example 4, and then we're moving to half-life, doubling, tripling. So I want you to do example 4. Here we have the number of fish in a lake is decreasing by 5%. So the I is going to be 0.05. As a result of overfishing, write an equation that represents the number of fish present after T years. So N is going to be T. If NO represents the initial population, so we have N sub O, and NT represents the final. And we know it's decreasing, so we know we have to subtract. So we're going to get final, which is N of T, equals initial, which is N of O. 1 minus 0.05 to the T. So we're going to get N of T equals N sub O, 0.95 to the T. So if they're looking for that one. Here it says, if there were 2,500 fish present in 2000, how many will be present in 2005? So did they give me initial or final? Is 2,500 the initial or the final? Initial, because it's in 2000. So we're going to get N of T equals 2,500, 0.95, and my T is 5. Because it's 2000 to 2005. So we're going to get 0.95 to 5 times 1,500. 1,934 fish. We have to round down no matter what. So here it says if there were 2,500 fish present in January 2000, how many would you expect in January 2005? I would expect 1,934 fish present in January 2005. Then it says how many years, should say an S, to the nearest tenth would it take for the fish population to reduce to half that there was in 2000? So there's 2,500 initially. That would get me 1,250. And then I would get 0.95 and to the N. I have my initial and my final, so I told you we always have to divide if we have both of those. So I get 1/2 equals 0.95 to the N. And then I do y1, y2. And it wants to the nearest tenth, so 1 decimal place. So N equals 13.5 years. Yeah. Yeah, T is actually smarter. Change 6. And then you write your sentence and you'd say it takes 13.5 years for the fish population to produce a half its number in January 2000. All right, so I'm going to post a one-page assignment. It's to work on, it's 4 questions. So you are going to just do those 4 questions, and then we're going to discuss them. They're not going to get posted, but we're going to discuss them tomorrow. Or on Monday, I think. Tomorrow we're going through the other 2 types, finish those 2 pages, and then we go through them all on Monday.